So, hello everyone. Myself, Srisha, and our team, Yashwant, Sumer, and Sunuka, we are going to discuss about the mini project analysis of the factors that affect air pollution, especially in India. What is the aim of this project? It means we are going to analyze the data of the air quality around India and how does it affect uh, on any other factors, as well as the factors that are being exposed to the air quality in every random city in India. So we are going to combine all the requirements from various websites and various data sets, and we are going to analyze using machine learning algorithms. So it consists the data set we are primarily consists of station code, sampling date, state, location, agency, type, sulfur dioxide concentration, nitrogen dioxide concentration, and respirable suspended particulate matter concentration and suspended particulate matter. So first, we have gathered all the data that is required for this analysis. So this data that we are borrowed is from government website, that is data.gov.in, one of the website, and other one is world.data.org, where we got those data, as well as many other sources from various websites. These are the data that is being rendered, or it is the data that we are going to consider. We are merging two data sets such a way that we can analyze more particularly on the required data, that is GDP, as well as nitrogen dioxide concentrations, SO2, RSPM or SPM. These are the data that is being rendered. This is the endpoint of the data. It consists of totally 4,35,000 of row and 13 columns. Now let's move to the visualization of these pollutants compared to the states. So we are going to compare the state as well as the type of the pollutant that is being affecting the air pollution. So it is visualized in the ascending order. We can see that from the analysis, Punjab is leading with the highest pollutant of SO2 in various factors, such as in industries as well as in vehicle combustions. And the other one, on the other hand, Nagaland from the northeast, it is the least SO2 pollutant for the environment or air pollution content. So the second analysis is nitrogen dioxide with respect to the state. As you can see, West Bengal is being in the highest position, where with the various factors such as vehicle combustion or industrial combustion is one of the major factors that being polluted to, that is a major factor for the air pollution currently in India. And the next one is particulate matter. It is also analyzed according to the data we are going to consider, such a way that it is in ascending order, sorted in ascending order. Goa, it is the least releasing state compared to that of Delhi. And the next one is RSPM, where Delhi plays highest role. As you can, for the current scenario, it is the main role where air pollution is taking place. Now we are going to for the statistical analysis, so that we can calculate the mean of the data. So first of all, we have to consider all the null values that is being considered, because that is not required for this analysis. So station code, there are various null counts, as well as sampling date, state, location, agency. There are some columns that are not necessary for this analysis. Station code, agency, sampling date, location monitoring stations are those columns that we are going to ignore now. And we are going to consider the missing values as the percentage, such as SO2 or NO2, whether we don't know what is the type of data that is being considered. We don't know what is going to happen with that data. and we are going to plot we are already plotted the bar plot where the amount of missing value that are being present in that data set. Now we are going to do the main thing of mean statistical analysis, that is mean distribution according to the state. So we are grouped them by SPM, SO2, NO2, RSPM, all these the value that are being provided in the data set, and we are going to find the mean of this. So we completed the main source where it affects the air pollution currently in this scenario. Then we are going to check the data distribution, how does data is being distributed using histogram plot. These are the data within the range which are the according to the chemical. First one is of SO2, NO2, and then RSPM as well as SPM also. So we are going to fill all these missing values by mean according to the mean. So this is where we are going to fill all the non-eligible or entry values with the some values. So we are going to transform these value, filling these mean value group by the state. After then, we are going to replace this null value with the mean. Using histogram, we are going to represent these in the histogram plot. This is the final data that is after the analysis for data distribution of the mean, we are going to obtain this as the endpoint. Now we are going to find out the air quality index for SO2 based on the formula. It is the formula that we obtained from internet to search how much the quantity of that is being calculated in case of air quality. I is equal to I low plus I high minus I low divided by C high minus C low into C minus C low. So these are the definitions where it comes in case of which type of gas it is being produced and how this affects the pollution. And these are based on the formula. We are going to search the quality, or quality index is being calculated here using those formula that is being provided here. I is equal to I low plus I high minus I low divided by C high minus C low into C minus C low. This is for RISPM, and this is for SPM based on that formula itself. And we are going to understand how air quality index is being, what is the range that is according to the AQI value, what is the present. We are going to analyze those. Now a new data, we are going to remove the another analysis for the hypothesis testing, where we are going to understand whether the hypothesis test remains true. Now further, I would welcome Ashwin to explain the further one.
Thank you, Shrisha. Now I'm going to explain how our variables are correlated. As we can see, our distribution is non-normal distribution, so we should use non-parametric testing. One of those tests is nothing but Spearman's correlation test, which uses two variables, and it gives us the plot between monotonic function. If this hypothesis fails, then our data has some problem. So as we can see, that our hypothesis testing got p value greater than 0.5, but that means we can use this data for further analysis. So next, so based on that, we have did chi-square test. After this, we got the value as we got exponential distribution as our distribution. As you can see, the value is least for the exponential distribution. So we can further decide this distribute our distribution as exponential distribution, which is non-normal distribution. So we have used non-parametric testing called Spearman correlation test for our hypothesis testing, which got p-value greater than 0.5. So we can do our further analysis on this data. So moving further, we have used logistic tried logistic regression, uh, where we have plotted x versus y graphs. X contains SO2, NO2, SOI, all these indexes which we have calculated before, and Y value contains air quality index, from which we can analyze which factor affects us more when compared to the other. And later we have imported linear regression model. Go down. And here we can see which factor influences the most and which factor influences less. We got the value of our regression as 0.97, and it will after prediction we have plotted each factor with the AKI to find the predict which gives the more accurate value. Then hold on. Wait. One second. Don't. Here we have did R square test, R square root mean square error for the linear regression. So we can see the values there. Then after this, we have considered doing some other classification test, that is logistic regression, which is we took the same parameters and tried tested there with the help of logistic regression model, and you can find the result which are not as accurate as that of linear regression. You can see the accuracy score is 0.6. In linear regression, we got 0.9. So we can consider this test is this classification is not that useful. Then we will use random forest classifier. Random forest classifier is nothing but it is one of the most famous algorithm, which contains many decision trees. Based on number of trees in the algorithm, the accuracy greater the number of trees in the forest leads to higher accuracy and prevents the problem of overfitting. So this gives us the accurate result, whatever we need. So we have imported random forest classifier from the sklearn model, and further we have tested and predicted all the results. Here we got the highest accuracy score of 96 point something, and after predicting we have got the correct answer. And the last algorithm we have tested is decision tree algorithm. It is nothing but the base part of the random tree classifier. Similarly, we have imported decision tree classifier, and we have found the accuracy, which is 0.99%. And we did some other predictions, and finally we can conclude that a quality index is highly correlated with all the independent variables such as SO2, NO2, RSPM, and SPM. Air quality index has been increasing over the years, as we know, even now it is increasing. Now the best model for the classifications are a random tree forest algorithm and decision tree classifier, where we got the accuracy as got the correct answers for correct solution for the problem. So now we can conclude that the air quality index depends upon the SO2, NO2, RSPM, and SPM, all these variables. So that is it from my side. Thank you.
Thank you, Yashwant and team for presenting this project. Thank you.